Hello, I'm Xing Tao, and my partner is Ruihao Zhang. This is our project proposal, Video Highlight Platform. This is the overview for our project. Our goal is to enhance video content with highlights. We've seen a surge in online video content. It highlights the need for the concise summary of longer video. Our project focuses on developing an advanced video highlight detection platform, use machine learning, React-based front-end, and a flexible Node.js or Django backend. So consequently, we want to offer a platform that generates immediate, relevant, and engaging video highlights to users across various genres of video. Here is the related work. Based on our research, we found one website. It called Video Highlight. It have like two general features. First, it has a time-saving functionality. So Video Highlight save hours of research time for users to focus on analysis and exploration. And the other thing is that there is a large user base for the Video Highlight. It's a platform that caters to the extensive note takers, such as researchers and students, so that they can quickly extract the key information from the video content and use it to study or learn or do anything. But there are several critical weaknesses of the Video Highlight platform. The first is the limited functionality. So the platform currently only provides summary and transcript functionality, limiting search capability. Here, I give an example of like search capability. For example, if some users want to find all the clips related to the event query like bike, they are unable to find them due to the limited functionality. And that's the thing that we want to enhance in our project. The other thing is the frequency of summarization. So summarization frequency is inadequately adapted to the longer video, leading to excessive highlight that may distort the main point. So for example, when I upload a video that is 1 hour long, it kind of like generates like 50 highlights, but it kind of totally destroyed the main point because there's too much highlights and it's unnecessary. Okay, so the third limitation is the genre adaptability. So the one-size-fits-all summarization fails to cater to diverse needs of different video genre. So some sports events and music videos I uploaded received inappropriate or irrelevant summarizations. Okay, so for our model, we want to select two database for the data preparation. The first one is a QV highlight, and the other is a TV song dataset. The QV highlight dataset provides over 10,000 YouTube videos paired with natural language queries, moment annotation, and saliency scores. So this comprehensive database allows us to train our model to generate personalized highlights based on our user queries. And apart from this, the TV song dataset is relatively small. It's just composed of like 50 YouTube videos from a spectrum of genres in order to validate our video summarization techniques. But together, these dataset will help us to train our model and generate the videos that are both personalized and accurate. Here's the approach that we use to build our model. So we aim to like based on the model that I already have, it's an end-to-end transformer encoder decoder architecture for the highlight detection. We want to enhance it by incorporating the user preference and behaviors for truly personalized and accurate experience. So approach involves like three major areas. The first is user-defined categorization, and the other is engagement metrics, and the third one is a view duration analysis in order to prioritize and identify the most resonating segments. So for the first part of this approach is enhancement for user-defined categorization. We plan to have like to let the users choose the type of the video that they want to upload based on this three categorization. First is the gaming category. So videos related to sports and esports can be manually tagged by the users. And the other is the entertainment category. It's content such as music or TV series or drama can be categorized as entertainment category. And the other is education category. So users can tag videos related to cooking, handmade art, and educational courses that teach you to do something. All these videos are incorporated in the education category section. The other thing we want to improve is to have a engagement matrix. So the engagement matrix is like the likes, shares, and comments of the video under the video. Normally we will find it during all the video platform, and we want to analyze it. So this system will incorporate the user engagement metrics to prioritize the segment with higher engagement, enhancing the precision of the high detection. So speaking of that, our goal is to resonate with the audience. So we want to identify the video segment that resonate the most with the audience, enable the model to mark them as potential highlight point. For example, if a video earns very high likes, shares, and comments, that segment of this video will be marked as a highlight. And the third aspect is the view duration analysis for personalized highlights. So we want to analyze the duration of the user spent watching a specific video segment to identify and prioritize segment of higher user interest.
Here's a feature of our platform. We have several pages. The first is upload page. User can upload a video file and input the keywords for specific highlight detection. And we have the home page for user to select their own video. And they can enter the playback page. This page supports the displaying of the highlight information and the online video playback and the timestamp-based jumping, so user can jump to anywhere of the video according to the information. And we need the model to generate the highlights and also the user authentication and web crawler. The web crawler is meant for periodically crawl videos for analyze. And here is the system architecture of our platform. It consists of an ML model to process video highlight detection, a React-based front end, and a Django or Node.js-based backend. We'll use AWS service to build the whole system. And our system will be built locally at first, and we'll set out our environment using Docker for local developments, ensuring a smooth transition when shifting to AWS. And here's our front-end design. It will be designed with a Figma, use React and related libraries like the Material UI for responsive design. It will mainly consist of the 3 pages that we introduced before. And the playback page includes an embedded player, the video highlight information displaying, and a timestamp jumping. It also includes some UI element designs, like a unique icon for videos in specific areas. And after implementing these core functions, we will implement the login interface and user features. And as for our backend design, based on the platform features, we will use a Node.js or Django. And the backend primarily includes some APIs for uploading user video files and invoking the analysis model, storing some operations and user features. And we need to deploy the servers at the AWS CS2 or Elastic Beanstalk. And here is our model serving server. The train model will be deployed on AWS EC2 Spot instance. It was supporting the API request from a backend server. This request mainly consists of the S3 video file link and other parameters. The analysis will return a response containing some highlight information, which the backend server will store for the access. And about the storage system, our storage system involves AWS RDS, S3, and DynamoDB. We will employ the RDS to manage structured data like the user data and file metadata, ensuring data integrity and security. The S3 will be used to store video files for its low cost and reliability. And for the highlight information, well, we prefer to use AWS DynamoDB or Redis because it's more suitable to store some NoSQL feature against the RDS. Here is a breakdown of our schedule. We have several checkpoints. The first, we will set up the environment and set up the Django backend and the basic structure of the front end. We also prepare the AWS and design the data structure and the APIs for our backend and create a basic version of the analysis model. And secondly, we will develop the core features. We will first implement the video upload and online playing functions and deploy the basic version of the front end and back end in the AWS EC2 and set up the AWS S3 bucket for storing the video files and initialize the RDS for storing in the DynamoDB. And we can also create a simple front-end interface. And after that, we'll finalize the machine learning model for highlight detection and deploy it and integrate the backend, front-end, and the models API and develop the front-end. And finally, we'll add some advanced features like refine the video playback feature or implement the user authentication in the cron job-based web crawler. Okay, thank you all.